I talked about the impact of climate change on the global average person. Then we talked about the distribution of these impacts, and I said that poorer countries are more vulnerable. And then I gave you the reasons for that structure of the economy, the fact that they tend to be in hotter places, and the fact that they tend to have lower adaptive capacity. And then we talked for a while about adaptive capacity, that it's not so much available technology or economic resources, but really a major component of adaptive capacity is the ability and will of the government to deliver large-scale infrastructure. If that is true, that countries at different stages of development are differentially vulnerable to climate change, then it also immediately implies that future vulnerability will be very different from current vulnerability. And we talked about it in the context of malaria, which is a disease that will get worse. So it's a disease of climate, but it's also a disease of poverty. And then we talked about scenarios of the impact of climate change on malaria, and said that there's many moving parts. It's not just climate that is changing, it's population that is growing, it's people growing richer, and there's of course advances in medical technology. And then I ended with some humility about our ability to project or predict the future. Now there was one little bit left in this, and that is the policy implications of everything that I just summarized. And that goes under the name of the Schelling conjecture. Schelling in this case is Tom Schelling, who won the Nobel Prize for something else entirely. He is was a game theorist. So mutually assured destruction, which is unfortunately relevant again, is something that came out of Tom Schelling's work. And also the idea of tripwires in East Berlin, that is Tom Schelling's work. He did a great many other things, and one of the things that he worked on and off since 1984 is climate change. And in the early 90s he published a bunch of papers where he asked two questions. And the first one you see displayed here. And the basic premise here is twofold. First, most emissions of greenhouse gases come from rich countries. The most vulnerable are poor countries. So if you reduce your emissions, you're actually not, as a rich country, you're actually not acting out of self-interest. You actually do this for people in faraway countries. And the second thing that he noted is that because of the long delays in emission reduction and because of the long delays in warming through the ocean and the slow workings of the carbon cycle and all those things, we're actually not doing this for ourselves, we're doing this for our children and grandchildren. So essentially climate policy in the United Kingdom is not something that primarily benefits the people of the United Kingdom today, but it primarily benefits people in places like Côte d'Ivoire and Bangladesh in the future, right? So Schelling noted this, and it's hard to dispute this, and then he asked the question, why do we care? Why do we, through our desire to reduce our greenhouse gas emissions, express a desire to help the children and grandchildren of the current poor, whereas through everything else that we do, it seems as if we don't care a whole lot about them. It's a very strange preference system that you have there. You say, well, I care about the Bangladeshis in 2050. If you look at our trade policy, if you look at our immigration policy, if you look at our military policy, they don't seem to care about the Bangladeshis in the year 2022. But we do care about them in the year 2100. That is very, very peculiar, right? So that is the first thing that Schelling said. There's no answer to this question. People have tried, but failed. And I think this is best illustrated with the cartoon you see here. This is a guy from the United Nations, that's what it said on his hat, who is busy worrying about reducing CO2 so that bad things won't happen to the grandchildren of the poor black guy that you see standing there, who is pointing to the graves of his children, so we won't have any grandchildren, right? So that is the first question that Schelling asked, and that's a question you should ask, but there's no answer to it. The second question that Schelling asked is also an important question, and there is a partial answer to this. So if we suspend our disbelief for a moment and assume that we really do care about the impacts of climate change on the descendants of the current poor, what is the best way of helping them? Do we take away climate change? Do we reduce our emissions? Or do we help them in some other way? Through, for instance, development assistance, or trade reform, or immigration reform. And this is a question to which there is a partial answer. Now, when Schelling asked this question, this was not particularly relevant. Schelling is a visionary, right? He works, typically worked on things 2 decades before anybody else did. By now, it is very relevant. What you're looking at is total official development aid from the OECD, the rich countries. So the development aid that comes from Saudi Arabia and other Arab countries is not in there. Development aid from China is not in here. So you just can add this all up, right, for the sum total from 1990 to the year 2018. In orange, you're looking at sort of your conventional development aid, which nowadays is mostly about building up institutions, helping countries collect taxes, keeping a land registry and all those sort of things, educating girls, all those things that we now know are terribly important for development. And then in green, you're looking at those development monies that are spent on reducing emissions in poor countries. And in blue, you're looking at those monies that are spent to help poorer countries adapt to climate change. And what you see is that an increasing chunk of money is now diverted away from development assistance, in the conventional sense of the word, towards climate change. And what you also see is actually that although all of that climate money is always promised to be new and additional money, if we just extrapolate the trend, you see, then it's actually not new and additional money, right? It's new and additional money in the sense that traditional development aid has stabilized and all the expansion goes to climate, but that expansion would have happened anyway, right? So this is not an irrelevant question. We are diverting money away from educating girls to building seawalls, right? And we do so to quite a substantial amount. We're talking about tens of billions per year. Now, Schelling asked this question, and we have answered it already, right? When I talked last week about malaria and about Bill Gates spending all this money on trying to develop and eventually succeeding to develop a vaccine for malaria. Now, that's actually a pretty damn good investment, right? Because it takes away the disease entirely, not just the climate part of the disease. And if you're worried, and people used to worry about what climate change would do to malaria, then you've taken away the concern in a much more direct and actually much cheaper way, because this program cost tens of billions of dollars, which is pretty small compared to the money we're spending on greenhouse gas emission reduction. So if you're in a situation like this where there is a sort of through investment in R&D, you can come up with a technical solution to the thing that you're worried about, in this case malaria, then yeah, this is a smarter way of reducing vulnerability, reducing the impacts of climate change than greenhouse gas emission reduction. Now, this is true in retrospect. I also told you last week that when Gates started this, everybody thought he was crazy. Many people were happy to take his money, but they thought he was crazy, that this was impossible to do. So in prospect, this was perhaps not the smartest project, but in retrospect, yes, this paid off. Now, the other thing that we talked about last week was Bangladesh and sea level rise. And there I said that the key problem was that Bangladesh has a rotten government. And really the best way of making Bangladesh less vulnerable to sea level rise is to replace its government by a government that cares and is competent. And that is not something that we can do, right? It's not something that we can say, well, we're going to invest $50 billion and the problem will go away, right? That is, actually, if you send $50 billion to Bangladesh, then chances are $50 billion thereabouts will end up in Swiss bank accounts, right? That is not how you solve this problem. The problem there is that you need regime change. And there's two problems with regime change. We've done it a couple of times in the past, not very successfully. We have changed regimes, right? But we did not necessarily replace the regime with something that was better. So that is a practical problem. And the other problem is, of course, that who are we to impose regimes on other countries, right? There's also a moral issue there. So in this case, if you want to reduce the problems of sea level rise in Bangladesh, then yeah, you can sort of encourage civil society in Bangladesh to perhaps improve the government, but really your best bet there is to cut your emissions and make sea level rise less substantial, right? And the other problem, of course, with development aid is that we now have some 60, 70 years of experience with this. Depending on who you listen to, some people say that we still don't know what to do. Other people saying that we now have a pretty good idea of what not to do, right? And that we're sort of beginning to get to, we know how to help another country develop. So in principle, yes, if we could stimulate economic growth in poorer countries, that would really reduce the vulnerability. Actually knowing how to do that has proven to be quite difficult. So Schelling asked these two questions. Both are important questions. One, there is no answer to, because this is your preference system. And the other is essentially an empirical question, but it's not a question for which there is a hard and fast answer. But it's important to keep this in mind, right? That if you're faced with a problem, be it sea level rise, be it malaria, be it something else that is worsened through climate change, then there's multiple ways of solving this problem. And if you care, then you should pick the best way of solving this problem, not necessarily the one that appeals to your green friends, right? So that is where I should have ended last week. So now this is the final bit of the 3 lectures on the impact of climate change. And I'm going to talk about 3 aspects. I'm going to talk about the impact of climate change on economic growth. I'm going to make a digression and talk about climate versus weather. And then I have a bit on climate and development. So this is where we are. Then next week we're going to shift to the cost-benefit analysis. But first we need to look at what does climate change do to economic growth. I've shown you this picture and you're sick of it. This tells you what would be the impact of climate change in a static sense. If you compare an economy that is 2.5 degrees warmer relative to an economy with the climate of pre-industrial times. And it's just a comparison, a static comparison.
Is it GDP?
It's welfare that we're comparing, right? I'm going to get to GDP, don't worry. And the assumption here is that there's no dynamic knock-on effects at all. This is just comparative statics, which is not how we think of economies. We think of economies as dynamic systems. So what could climate change do to the growth path of an economy? Now, I think a good starting point is to say, well, how does climate change actually affect welfare? And it does so, I think, through 4 alternative channels. The first one may be that there's a direct impact on utility. And an example of that is the loss of species. If a minor species of whales goes extinct, and the major whales are still there, so all the tourism associated with all the whale watching is still there, then yeah, we would feel sad about this, but it would not really affect the economy, right? So that is a direct impact on our utility. And it doesn't change our behavior, it doesn't affect the economy in any other way, right? But there are other impacts of climate change as well. Climate change may affect the labor supply, and we talked about impacts on human health. I treated that as in and of itself, right? Which is probably the most important thing. But if more people are ill, then they don't go to work, right? So you have a reduction in the labor supply. And that means that you have a reduction in your economic output and GDP falls, right? May also be that the output per worker falls. If your crops don't grow because the weather is bad, worse than it used to be, then output per worker falls. The number of workers may fall, but also the output per worker can go down. The final effect that is listed here is that climate change may increase the rate of depreciation of your capital stock. If your buildings are blown away by a storm, if your bridges are washed away by floods, then you've lost part of your capital stock, right, in economic terms. And in a model that would pop up as an increase in depreciation. Now, as I said, if climate change affects utility directly, there is no further economic impact. But in the other 3 channels, or in the second and the third channel, you have reduced output in period T today. Your impact, your economy is smaller today. Now, if you have less income, then it stands to reason that there's lower consumption, and that of course affects your utility, but also you have lower savings. And if you have lower savings in this year, that means that you have less investment, because savings equals investment, right, in the macroeconomy. And that means that you have less capital next year. And if you have less capital next year, you also have lower output next year, right? And the same is true if part of your capital stock is washed away, then you also have lower output next year, right? Because part of your investment goes to replacement rather than expansion of your capital stock. Now, you may object that we're going to make this up by additional savings, right? If output falls now, then we're going to save more and therefore invest more to make up for the shortfall. But that would actually be irrational. Because climate change is a structural problem, right? If climate change has reduced your output this year, that means that the productivity of your investment has fallen, the productivity of your capital stock has fallen, and that means that your returns on investment have come down too. And if you think that climate change is structural, then you say, well, what happened to me in the year 2022 is likely to repeat itself in 2023 and in 2024 and in 2030, right? So if my harvest is bad this year because of climate change, then you can expect bad harvests in the future too. So you would invest less because the return on capital, return on investment has fallen. Come in. So you would actually save less, not more. Right, so that is the rational response. The behavioral response is, of course, well, my output has fallen, so my consumption goes down, and now you want me to save more, right? You want me to reduce my consumption even more so that I can make up in the future. Behaviorally, this doesn't compute, right? So if anything, savings should come down, not go up. You may object that, well, if the impact of climate change is primarily through a shrinkage of the labor force, then the implication is, of course, that you have more capital per worker, right? Because there's fewer workers around. So higher labor productivity, more capital per worker, higher labor productivity, higher wages, this is all good, right? But again, the rational response, as you recall from your macro, is to consume the windfall until the capital labor ratio is back at its equilibrium value, right? That's how solar models work, right? And the only real exception to this is really if your labor force falls very, very, very rapidly. So we're in a sort of Black Death sort of situation. And only then you can sort of like say, okay, we go through a period, a few decades of absolute misery, but then in the end we have much, much more capital per worker, much, much more land per worker, and we sort of like, the economy starts booming again. Now, two things there. One, economic historians are still arguing about whether or not the Black Death in the long run was good for the economy, and the empirical evidence sort of suggests, yeah, in Western Europe, no, in Eastern Europe. And of course the price was quite high, right? And there was also a lot of institutional change. It wasn't just the economics. But these sort of effects are not on the cards for climate, right? Because most of the effects, the health impacts are for the very young and the very old, right? People who are not economically active. And we're definitely not talking about killing off a third of the people, right? So really, you should focus on this. So the possible countervailing forces are not very strong and may actually work in the opposite direction. So if we have negative impacts of climate change on the economy today, then that has knock-on negative effects in the future. So far for the qualitative story, let's look at a calibrated model. This is somewhat older work, so it's in black and white. At the very bottom here, the diamonds, you're looking at the assumed direct impact of climate change. So this is the comparative statics that we talked about before. We're going 2 centuries into the future, and those direct impacts go up to some 12, it's hard to see from that angle, some 13% of GDP in the end. So that is the direct effects. And now the other 4 curves that you see look at the implications of growth. And these are the indirect effects. So the total impact is the sum of the 2, right? And essentially this is how much does the economy slow down and how much poorer are we as a result. So the bottom line that you see, you actually can't see it. So let's focus on the triangle. That is the solo model, and that is the one that we've been building in the seminars. So a solo model is very simple. You have one capital stock, physical capital. Savings are given. Savings are 20% of GDP, right? If that is how you represent the economy, then you roughly need to double the impacts that I showed before. Because the knock-on effects on economic growth are the same order of magnitude as the direct impacts. So the total impact is double of what I said before. Now, under the Solo model, there's the Ramsey model. And the difference between Solo and Ramsey is that in Ramsey, the savings rate is not fixed, but it's optimized. So now people can adjust their savings behavior and therefore their investment, and it actually gets slightly worse, but you see that actually this whole savings mechanism doesn't make a big difference. Now, these are so-called old growth models, which suggest that there's also new growth models, and they are the ones that you see on top. And they are the Menke-Romer-Weil model at the very top, and the Romer-Romer model at the bottom. And the Romer who is in both is David Romer. And the other Romer is Paul. There's the Nobel laureate, Paul Romer. And in both of these models, technological change is no longer exogenous. So recall the model that we're building in the seminars, total factor productivity just improves, right? And we don't have to do anything for it. Just a year goes by and it's 2% bigger, right? That is, of course, not how it works. In the Romer-Romer model, you need to invest money in R&D. And you need to reserve part of your capital stock and part of your labor supply to invent new things. As a result, the solo residual is no longer a residual, but it's now part of your economy. And as your output shrinks, also your investment in R&D shrinks. And you actually get a worse impact on climate, a worse impact of climate change and economic growth, right? And that makes hopefully sense. It's just more of your economy is susceptible to climate change. In the Menke-Romer-Weil model that you see at the top, and in the Romer-Romer model, this effect is actually fairly small. In the Menke-Romer-Weil model, technology is also endogenous. It's part of the model, but now it comes through human capital accumulation. So you're educating people and you reserve part of your capital stock, you use part of your labor supply to educate people. And then of course, if your output falls, then you educate less and that has knock-on effects. If that model is true, then you should not double the impacts that I talked about before. You should not double the static impacts, but you should triple them. Right? Now, of course, the question you have is, should I believe Romer or should I believe Menkev? And the answer is, you shouldn't believe either. If we apply the Romer model and use it in a cross-sectional sense, then it turns out that the predicted income gap between rich and poor is smaller than observed. So the model is not sensitive enough. Whereas the Menkev-Romer-Weil model predicts a wider income gap between rich and poor than is observed. So the Menkev-Romer-Weil model is too sensitive, right? So the reality lies somewhere in between these two. But we don't know quite where or how to model that, right? So, takeaway message, the static impacts that I showed you before are an underestimate of the true impact of climate change, right? Now, you may ask what happens to the growth rate of the economy. What you're here looking at is the impact. So this is the growth rate of the economy. It's assumed here without climate change to slow down. We talked about this before. That is because the assumption is that as population ages, they become less creative and the economy slows down. So that is why we have a baseline of slowing economic growth. And then we impose climate change according to the four models. And you see, yeah, the economy, sorry, no climate change. With climate change, the growth rate of the economy is lower, but it doesn't turn into economic shrink, right? And we'll get to the importance of this in week 9. And you really need to pump up so this is for the Menkev model, the most sensitive model. You really need to pump up the impacts of climate change to quite high values to reverse economic growth, and then only in the very long run. If you use the solo model instead, then yeah, reversing economic growth is actually fairly hard to do. So much for the theory of all this. Is there empirical evidence? It's Melissa Dell, who you see displayed here, the Clark Medal winner of a few years ago, who was the first to ask empirically the question, what does, in this case, weather shocks do to economic growth? And here you see the key table, or the table of key regression results in this paper that was published now 10 years ago. The dependent variable here is the annual growth rate. And the independent variable, the explanatory variable, is the average temperature of that particular year. And what you see is that temperature actually has no significant effect, right? That's what the stars or the lack of stars mean. But if you interact temperature with being poor, you see actually negative effects and significant effects. And not just statistically significant effects, but also economically meaningful effects. So the 1.7 that you see here means that your economic growth rate has fallen by 1.7 percentage points. So instead of growing 3%, you grow by 1.3% that year, right? So these are big numbers, very big numbers. The average is actually 1.4 rather than 1.7 because you need to subtract the 2.6 that you see there. 0.26 even. So these are big effects, right? The question is this correct? And that is the I'm looking at the timer here. It says, I have two timers on my screen. One says I've talked for 35 minutes. The other says I talked for 19 minutes. And I should ignore the 19 minutes, right? I've talked for 35. Anyway, the problem with studies like Melissa did is the confusion between the impacts of weather shocks and the impact of climate change. 2 weeks ago I talked about, no, last week actually, I talked about how to estimate the impact of climate change, and I pointed you to these Ricardian studies that looked at sort of variations of climate over space and then sort of like transposed that relationship to assume that it holds over time. And the big difficulty with this is you need to make all sorts of assumptions, but there's also all sorts of confounding factors over space, things that are different between countries, just as the climate is different between countries. There's all sorts of other things that may explain the different incomes that are there. So this is problematic. What people have also tried is to look at estimate the impacts of climate change over time on economic growth or economic development, but the problem there is that for the period over which we have had good data, it's from 1960 onwards, climate actually hasn't changed that much, whereas a great many other things have rapidly changed. So again, you have a problem with confounding, and you have a problem that your initial signal simply is not very strong. So estimating the impact of climate and climate change is actually very difficult empirically. So what people have done instead is estimate the effect of weather on economic growth and all sorts of other economic indicators. And that is what is going on in this table. This is not climate, this is weather, right? It's the annual temperature that goes in, not the 30-year average temperature. If you look at the impact of weather, then econometrically you can make a causal claim, because there's actually disagreement here whether weather is random or not, and meteorologists could bore you for hours about that question, whether it's truly random or not. But from an economic perspective, weather is random, right? Or at least it's orthogonal to the economy. So a claim of causality is very easily made. You have way more weather observations than you have climate observations, because weather comes every day, right? Whereas climate comes every 30 years. The problem is, if you have estimated the impact of weather shocks on an economy, can you say anything about the impacts of climate on the economy? And the answer is no, not really. Which is unfortunate, because by now there's a whole bunch of studies that try to do this. If you ask a meteorologist or climatologist what is the difference between weather and climate, you get answers like you see here. And essentially climate is what you expect and weather is what you get. Climate is the 30-year average weather, right? And that also means that adaptation is different. So if it rains, what you do is you put up an umbrella. And if it pours, what you can do is you can close the floodgates. Right? That is the extent of your response to a change in the weather. A change in the climate is different. If you used to live in the Arabian desert where it never rained, you did not need an umbrella, right? And if now, because of climate change, you have occasional showers, then you can buy an umbrella, right? And you have that particular option. Or you could build those floodgates, right? If you have a forecast of heavy rain for the next 5 days, then the only thing you can do is close the floodgates if you have built them already. But of course, if you have a forecast that in 30 years' time we will have more flooding, then you can build those floodgates between now and then, right? So with climate change, you have a much wider range of responding to the threat than you have with weather, right? Or in other words, if you estimate the impact of annual variations in temperature on economic growth, what you have estimated is the short-run elasticity. But if you want to know what happens if it is systematically warmer, then you need to estimate the long-run elasticity, not the short-run. And short-term and long-run elasticities are different. And the difference between the short-run and the long-run, of course, for those of you who need reminding, is not time, but it's a question whether or not your capital stock is fixed or can be changed, right? That is the difference between the short run and the long run. And of course, you can also develop new technologies. You can invent new things. So technology is also different in the short run and the long run. So no, you cannot just take those weather studies and apply them to climate. And if you do, things can go wrong. This is, I don't have a source here. This is from a paper that was published last year by Newell, Preston, Sexton. And there's essentially what they did was they took the Melissa Dell work that I showed you before and then did a systematic robustness check with essentially systematic specification test, and essentially ran every model that they could possibly think of, and then sort of like how well does these models perform in sample and what do they predict out of sample. And let's start with this, which is a model that makes somewhat sense, where the change in economic output, so the growth rate of the economy, is a function of the change in temperature. What you see is that equally credible models that perform equally well within sample give widely different projections out of sample. Some say, well, climate change will stimulate the economy. No, that's actually not what they say, because zero is here. I was looking at the zero there. So climate change is always bad, but the effect varies somewhere between 0.5% and 5.5% of output, right? Which is order of magnitude difference. If instead we say that economic growth is not a function of the change in temperature, but of the temperature itself, then you get this histogram where the numbers are far larger, right? Here we run from -6% to 0. Here we run from -100% to +100%, well, to +60%, right? So you can't even agree on the sign of the impact. And economic growth just explodes, right? Much, much faster. And here the economy completely collapses, almost completely collapses. And you see just essentially you can't say anything, right? Essentially there is no information in this at all. Now this specification that you see here, I'll come back to that after the break, makes a very peculiar assumption, right? It says that the growth rate of the economy is a function of the temperature, which means that if climate continues to warm, say to 2 degrees, and then global warming stops, then economies will continue to grow at a different rate. Even though climate change has stopped, the impact of climate change has not. And here, if these models are true, we're sort of forever trapped in a low growth economy, right? Which is a very peculiar assumption to make. So you should be very careful with these weather studies. Now fortunately, there's also one paper that I think does it properly. That's by Eric Strobel and colleagues. Eric is here. He ended up as the third author, but he is the one who actually did most of the work. And what you're looking at here are results again for the growth rate of the economy. Now the growth rate of the economy. No, it's the growth rate of poorer economies across the world. And the effect here is not year-to-year variation in rainfall in this case, but it is the secular trend in rainfall. And again, you see rain is the one that we're interested in. You see a lot of significance there. You see positive effects of rain. That is, wet is good in sub-Saharan Africa. But the problem in sub-Saharan Africa is that the rains have failed, right? So rain is good, but the rains have failed, so we see a negative effect on the economy of sub-Saharan Africa. And this is a secular trend. This is not a year-to-year variation. And that is illustrated in this particular graph that you see here. Now it's a little bit bigger. So there's 4 series drawn here. This solid line is economic output in sub-Saharan Africa as observed, right? And what you see is that they've grown, but only a little bit. This dashed line that you see here is a sample of countries that started off at roughly the same position as sub-Saharan Africa did. So this is a lot of countries in South Asia and in Latin America. And what you see is that compared to those countries, sub-Saharan Africa actually did pretty poor, right? It's about half of the economic growth that was recorded in countries that in 1960 looked very similar in terms of structure of the economy, education, and so on and so forth, right? Now, these 2 lines are the ones that are interesting. So they come out of the regression results that you see here. Model A and Model B. No, Model A and Model B. Model 2 and Model 5. And that is what would have happened to sub-Saharan Africa had the rains stayed as they were in the 50s and the 60s. Right? So they run the same model, but now with artificial weather rather than observed weather. And they kept the rainfall patterns as they were, what is it now, 70 years ago. And depending on the model, what you see is that either sub-Saharan Africa would have done better than South America, or it would have done slightly worse, right? So really what you see here is that the trend towards longer and deeper droughts in sub-Saharan Africa really had a negative effect on their economy. And this is climate change, this is not weather change. Okay, final chapter, climate and development. Cool countries tend to be rich, hot countries tend to be poor. I said it before, it's very hard to deny this. Here we're looking at the pattern of temperature in the year 2000 versus per capita income in the year 2000, and you see a negative correlation there. If you push this back to 1950, you see that the correlation is actually stronger. The exceptions here are the oil countries, right? The OPEC. Relationship is there, it's a bit stronger. If you push it to 1913, the relationship is there. Strong negative correlation, same in 1900, same in 1870, same in 1820. Of course, we're dropping countries as we go along, but the negative relationship is there. Same is true in 1800. And in 1750, sort of the relationship disappears and may have tilted the other way. Same is true in 1700, 1650. 1600, and if you go back to all the way to year 1, you see that it's actually reversed. So definitely for the last 250 years or so, cool countries tend to be rich, but hot countries tend to be poor. So that correlation is indisputable. The question is there a causal relationship? And of course, if there's a causal relationship, that hot countries are poor because they are hot, then potentially we have a problem with climate change, right? That is bigger than the ones I've been talking about before. Now, opinions are strongly divided about this, and I'll walk you through it without actually answering this question. Jared Diamond, not an economist, but a fairly influential guy, argues with a whole bunch of ancient thinkers that climate and geography are destiny. That poor countries are poor because they're hot, and rich countries are rich because they're cold. And he puts a number of arguments forward. One is, it all goes back to agriculture. One is the number of plants that can be domesticated. It just happen to differ between places and tend to favor more temperate places. The other is the axis of continents. So on the Eurasian continent, it's essentially, it stretches from east to west or from west to east, which means that if you domesticate rice in China or you domesticate wheat in the Middle East, you actually have a whole band of continuous climates where you can plant this successfully. Whereas if you domesticate sorghum in Africa, because the orientation of Africa is north-south, yeah, you can grow sorghum in southern Africa, just as where you domesticate it in northern Africa. But in between you have so different climates that this crop is essentially useless in between. So you have much less of a space to sort of like transmit your new inventions to. And that matters quite a lot according to Diamond. The Americas are also north-south, which is why the American civilizations started much later than Eurasian civilizations. And then, of course, the book that he first poses in is called Guns, Germs and Steel. Of course, by the time the Europeans got to the less developed, less further along Americas, they also brought their germs with them that we had sort of acquired from our domesticated animals, right? That's where most of our diseases come from. But when they were introduced to a naive population, they sort of wiped out a good few. So that is what Diamond argues, that, yeah, in every scenario, in every conceivable way that our history may have unfolded, Eurasia would always have come out on top, would always have dominated Africa, would always have dominated the Americas. He also has a story about why Europe and not China, and that is because Europe is geographically fragmented by big rivers and mountain ranges, and that meant competition between states, whereas China has always been united and there was never competition between Chinese states because there's no big rivers and no big mountain ranges in China, if you believe Diamond. At this point, I see Hinch looking up. At this point, Diamond really shows that he's never been to China, never read a book of China, never studied its geography or its history. Right? He's just completely wrong here in everything he says. China versus Europe. But that is the argument that he makes. And the fact that Eurasia would always come on top does not rest on a misreading of history or geography. There's some empirical evidence for this. Olsen and Hibbs published a paper in 2005 in the European Economic Review, where they just run a regression on current development levels on such things as the availability of domesticable species of plants and animals, and it turns out that is significant, and also on the axis of the continents, and that also turns out to be significant. And these sort of effects remain if we also control for politics and social capital and all those sort of things. So there is some empirical evidence for this, but not particularly strong, I would say. Jeff Sachs is often accused of being an environmental determinist, just like Diamond is. For Diamond, geography is destiny, right? This is environmental determinism in its simplest form. Sachs has a more nuanced position, and he argues that climate and geography are important, but not predominant. And his two main arguments are distance to markets, not as the crow flies, but as the ship sails. So if you're near a big river, then you're better off because you're closer to markets. If you're near the sea, you're closer to markets. And he also makes a big deal about malaria. So malaria we talked about before, actually a big killer, also affects how many children people have, how well educated they are. Malaria, I talked about last week, actually kills a lot of people. But those that are not killed by malaria are actually stunted. If as a child you contract malaria, your brain doesn't grow as fast as it would have had you not had malaria. And if as an adult you still have malaria, but then you're immune, right? You're not immune, but it won't kill you, but it does make you ill and unable to work. And he argues that malaria is therefore important. And again, there is empirical evidence to support this. This is income per capita. What you see is that the distance to the main markets, that is London, New York, Tokyo, as the ship sails, turns out to be significant. But also the area of a country that is malarious is significant. And the more malarious your country is, the worse your income. So those are two theories that are out there. Now Sachs is a very controversial figure, and he likes controversy. And this paper, published in 1999, attracted somewhat of a reaction. And the main guy in this, you see here, Darren Acemoglu, who makes a different argument. And the argument, the Acemoglu argument, is that climate and geography were important in the past. They shaped the way countries are governed, they shape institutions, but once that shaping was completed, climate is no longer important. The key argument comes in this paper, 2001, in the American Economic Review, where they run sort of the Sachs regressions, and then they start controlling for things. And what they argue is that as soon as you control for institutional quality, rule of law, security of contract, higher education, once you start controlling for these things, then the effect of geography disappears. Climate is no longer significant. It simply loses in a horse race between the two. But then he runs a regression of these institutional indicators on the European settler mortality. And what they did is they went into the archives of the English and the Dutch and the Spanish and the Portuguese, and what happened to their soldiers when they arrived in places to conquer and colonize. And what they found is that in some places Europeans just dropped dead, right, essentially, because can't handle the disease environment. Whereas in other places, Europeans felt quite happy and settled. And that is essentially the variable that you see here. So the causal story, and it turns out that this particular variable actually can explain institutional quality quite well. And then institutional quality explains the pattern of economic development. And the story is something as follows, that in those places where Europeans were healthy, they came and they settled. So South Africa, Australia, North America, the Europeans came, killed all the locals or drove them off their lands, and then created essentially a European society with the rule of law, with higher education, and so on and so forth. And those places are still quite wealthy. Whereas in places where Europeans did not feel very healthy, as measured by the number of soldiers who died within a year of arrival, Europeans came and essentially they plundered, right? The colonization model was essentially you go in, you grab what you can, and then you run away as fast as you can. And in those places, they were essentially plundered, all the local institutions were smashed up. When the Europeans left, they essentially drew arbitrary borders, and so on and so forth, and the result is a big institutional mess that explains why sub-Saharan Africa is still so very poor, right? That is essentially the story that you see here. And for us, the important thing here is that the argument is climate used to be important, but it is not any longer. And if climate is no longer important, then climate change is irrelevant too, right? Now, it was not just Adjumolu who did this. Easterly and Roderick wrote similar papers. Important. I don't know why that is still not there. There's a bunch of papers that say, well, actually you can explain variations within countries partly by climate. There's another paper out there that says, yeah, forget about climate, it's actually UV radiation that matters. It's a very confused debate. And I think the strongest paper in this whole suite is by Marcella Alsan, who you see here, also a Bates Clark medalist. Now I pause because I'm not sure about that. I think she won. Who actually argues that it's the cheche fly who did it. So in Africa you have this fly, the cheche fly, and what it does is it kills animals. Humans are not bothered by this, but essentially you cannot have cattle in parts of Africa because of this disease. And she looked at this and she compared this part of Africa to South America, which has a very similar climate, but not the cheche fly, and looked at institutional development. And essentially the argument is that if you can't have cattle, then you don't have access to a lot of meat, you don't have access to dairy, but you also don't have access to draft animals, right? Because it's the cows, the oxen that do the plowing. And then if you can't have the oxen do the plowing, then your wife has to drag the plow, right? And they are less strong than oxen, right? And that creates then a sort of an institutional separation or a different institutional development. You have less centrality because you can accumulate less wealth. You also have less central government. You have, that's where I started, you have different relationship between the sexes and so on and so forth. And she convincingly, I think, argues that, yeah, in those places where you had this disease, you have different institutions than in those places where you did not. And this is a climate effect, right? Essentially. So, three very different views on this, right? Climate is destiny, climate is important, but not predominant, and climate is something of the past, right? And this matters quite a lot. I am somewhere in the middle, not quite as Sachs as Sachs, but somewhere in the middle. The reason that we need to worry about this, even if the empirical evidence is weak, has to do with the potential of poverty traps. And this is essentially Sachs' story, right? So if infant mortality is high, if a lot of your children die at very young age, and this is true in places where there is malaria, then as a parent what you need is many children, right? You need to have many children to make sure that some of them survive to adulthood so that they can take care of you in old age. And if you're risk averse, not risk average, then you would actually get more children than you really need. Because then you're absolutely sure that they survive. Now, that has a couple of effects, right? Just the sheer effect of having more children puts a pretty heavy burden on the mother, right? And takes her out of the labor force for longer. But also, if you have a great many children, then your resources are spread thin, right? So you can't feed them properly, you can't school them properly, you can't keep them healthy properly, because all of that costs money. So this is then a poverty trap, right? So if you're in an area that is so poor that you can't protect your children against malaria, you can't afford bed nets, you can't afford medicine, then you will have many children. Those children will be poorly fed, they will be poorly educated, so they grow up to be poor themselves, right? So you're sort of in this vicious circle that is known as a poverty trap. And the starting point here is climate, right? And if this is the case, and in a future climate, more places would be trapped in a malarious climate, or more places would be in a malarious climate, and more people would be trapped in poverty. And then we are no longer talking about growing at 3% or growing at 2% per year, but we are talking about growing at 3% per year versus growing not at all, right? Poverty trap, you have a stagnant income, or rather an income that variates around the stagnant mean. There's other mechanisms that would do the same thing that are related to climate. There is some evidence that in those places where there is a risk of losing it all, be it to a drought or be it to a warlord, there is essentially no point in saving for the future, right? If nature can come and take it all away, or some militia can come and take it all away, then what is the point of saving up? And these are known as feast and famine cultures, that you have a party when times are good and you just hope to survive the bad times, right? And in these cultures, saving for the future makes no sense, which is sort of probably the right thing to do when you're talking about cattle or other physical things. Of course, education is not something that a drought can take away, right? But sometimes this sort of attitude that it doesn't make any sense to save for the future, that time is circular, we just go through feast and famine, rather than time is linear and there is a chance that we improve ourselves over time. If that gets ingrained in a culture, then there is also no point in investing in education, right? At least in the minds of the people. And there is increasing empirical evidence for this. The guy you see at the top, Evert van der Vliert, is a social psychologist who I don't know how many papers he has written about this, but he has correlated everything under the sun to climate. And he finds robust evidence that things such as depression and aggression and xenophobia and autocracy and individualism are all associated with climate variables. But these are associations, they are not causal relationships. This guy here, who is really much nicer than he looks, Oded Galor, and this is really what he looks like on his better days, has causal evidence, right, that in those places where crops grow better, people have developed what is known in the jargon as long-term orientation. They have lower discount rates. Whereas in places where agriculture is hard, people are much more focused on the short term. Whereas in farming cultures, you need to plan ahead, right? You need to save your seeds, you need to sow before you can harvest. And that seems to be a causal relationship. And he has also shown that in places where there's more variability of the weather, so longer droughts, greater floods, or bigger temperature swings, then people actually become loss averse. They become more risk averse, less willing to take risks. And both of these imply, so a lower discount rate and a lower risk aversion imply higher investment, right? So going back to the feast and famine Some people just don't see the point of investing in the future, whereas there seems to be a systematic correlation or even causation from climate effects to your attitude towards risk and towards the future. If true, then indeed in the very deep past, sort of the places where agriculture developed first, those are also the places where you have more development, right? And then Andrea Matranga has a paper out, not published yet, where he also ties the agricultural revolution to the climate changes that just took place just after the end of the last ice age.
Could you explain long-term what long-term orientation means?
Long-term orientation is a term that was developed by Geert Hofstede, who is a sociologist. So in the jargon, this is known as long-term orientation. This essentially means, do you keep your eyes on the future or do you keep your eyes on today, right? Economists call this the discount rate, right? But it's because it comes from a non-economist. It has this, to us, peculiar, but to a layperson, much more intuitive term, right? As I said, these debates are unsettled, right? I very rapidly took you through some papers here. If it is the case that people are poor because of the climate, and there is really a causal relationship here, then of course climate change is a big problem. Because as I said, then the difference is not, do you lose 2% of your well-being, right? Do you lose 2% of your income? Does your economic growth rate fall from 2% to 1.5% per year? No, really, if you're trapped in poverty because of climate, and the area where people are trapped in climate-related poverty expands because of climate change, then we are talking about growing exponentially versus not growing at all, right? And that is by far the largest effect. It's an enormous alpha loss. But as I said, this is all very speculative, and I started, or my second point was Sachs, right, who is often accused of environmental determinism. But with Sachs, he also immediately says, but we can solve these problems, right? Definitely with malaria, we can solve these problems. Infectious diseases, we can solve. Cultures are not static. You guys think differently than your parents do about a great many things. Cultures are not static. So there's no ground for fatalism, but it is definitely a source of concern. That's all I wanted to say.